Okay, welcome to JC Connect. In the previous class, we were discussing about the slow sand filtration process and the rapid sand filtration process, um, and what are the differences will be there for the slow sand filtration process and the rapid sand filtration process. Of course, when it comes to the space requirements, uh, the space requirements, it occupies large area, it occupies small area. As the name indicates, the rate of filtration is very less in slow sand filter. In rapid sand filter, it is more. Then the effective size of the sand, what we are talking about in your geotechnical engineering, that is coefficient of uniformity. Okay, so this will be discussed in your geotechnical engineering. So what will be the uniformity coefficient? Okay, so for example, you have around 10 particles. Assume that you have 10 particles. So in these 10 particles, how many particles are similar of size? Okay, for example, 8 particles. 8 particles. If they are similar, we can say it is 80% are having the uh, means the uniformity will be there. Okay, then the coefficient of uniformity it will be 0.8. Okay, with respect to all dimensions, you can say if it is circular similar size, so then it will be circular. Okay, then the preliminary treatment is required before coming to the slow sand filtration is or not, that has to be decided here. Okay, so in slow sand filtration process, normally plain sedimentation is required. Okay, only the plain sedimentation is required before the water is entering to a slow sand filter. Okay, but in case of the rapid sand filtration process, um, it requires chemical coagulation and sedimentation. Both it is requires. Why? Because um, without preliminary treatment, suppose if you send the water to a filtration process, see, we have discussed some of the mechanisms like aeration, screening, sedimentation, coagulation, and filtration. Suppose directly, if this is the water, raw water, assume that the raw water, here it is there. So this is what the our main thing. This is what the mechanism. But suppose if you bypass this, assume that if the raw water, if you are bypassing and if you are entering directly to a filtration process, okay, then the whatever the efficiency you are expecting for the filtration process, it will be very less. Okay, so if you want to increase the um, filtration process efficiency, then you should go for plain sedimentation, and you should go for chemical coagulation followed by sedimentation process in rapid sand filtration process. Okay, then washing. So, for example, if all the filters are blocked, assume that this is a filter bed. Assume that all the complete, if your filter is blocked, okay, if your filter is blocked, then how exactly the filter can be cleaned? Okay, how the filter can be cleaned? So here we have this scraping mechanism. So one scraping mechanism will be there. For example, if any particles, if it is going to accumulate, this will be removed with the help of the scraping mechanism in case of slow sand filtration process. Here it is backwashing. I already explained how exactly the backwashing is going to work out in rapid sand filtration process. Then operation, less skilled persons are required for slow sand filtration because the mechanism is very simple. Okay, even they are very less skilled, so then no problem. But here it is highly skilled persons are required because as it involves backwashing systems. So when to provide the backwashing systems and what rate we have to supply the rate and what rate we have to supply the water from the OHT tanks. So that will be decided here. Okay. For that, you require a skilled person, that too a graduated person. Okay, especially from this field only. Okay. Then loss of head allowed, that is 4 feet, and here it is 6.8 feet. It's a lot of head in the sense, above the filter, above the filter, how much depth of water it is retaining. Okay, how much depth of water it is retaining or it is remaining. Okay, that has to be decided. Then removal of turbidity, good. Okay, removal of color. Okay, here it is fair and good. So removal bacteria it is 99.99%, but here it is 98.99%. Okay, here it is lesser. Here it is more. So then, normally the filters are designed depending on the quality of water, the raw water what we are talking about. Previously, I have given an things that this is what. Okay, so raw water, aeration, screening, sedimentation, coagulation, filtration. See, most of the water treatment plants, okay, the kind of units we are providing. Okay, suppose if you are deciding aeration, if you are deciding a screening, on what basis you have decided whether the aeration is required, whether the screening is required, whether the sedimentation is required. See, on what basis you are going to design it. So ultimately it depends on the raw water quality, remember. Okay, it depends on the raw water quality itself. Okay, it depends on, suppose if no sediments are there, okay, if no colloidal solids are, if no pathogens are there, then why you should provide all these units. Okay, if the if the raw water quality is 100% pure, okay, which is following the norms what we have discussed, that is IS 10,500 2012. Suppose if the raw water quality, if it is satisfying the norms of the IS 10,500 and 2012, then why should we provide the water plant directly? We can drink it, is it? The raw water quality, if it is satisfying with this norms, whatever the drinking water quality standards, then there is uh, no problem, or there is no use of providing the water treatment plant. See, ultimately you are wasting the money. Then ultimately first the thing what you have to do is that before deciding any of the water treatment plant, first you should check the quality of water. Okay, you should check the quality of water. Then once you check the quality of water, what composition it has, based on that you have to design. Sometimes you can remove the aeration. Okay, only you can provide the screenings. Sometimes you can provide only the filtration process. Okay, directly filtration process without going for sedimentation and all those things. Okay, so that has to be decided based on the quality. Okay, then filter type, what kind of filters you are using. Okay, I already discussed the types of filters, that is whether you are going for the pressure filters or whether it is gravity filters, that we already discussed. What way it is suitable, what way it is suitable, that has to be decided um, in this designing stage. Then process and hydraulic loading. Okay, so what kind of uh, process is involved. Okay, whether it is a backwashing system or whether it is a slow sand filtration process or whether it is different types of processes have been involved. Then what kind of how much loading you are doing. Okay, hydraulic loading in the sense, see, normally it is flow rate. Okay, see how much flow rate or how much quantity of water you are filtering. how much load you are giving to that filter. So that depends. Suppose if your expectation is very less, okay, which one is suitable? Which one is which is suitable? Okay, which is suitable. If you are expecting more, or if the demand is more, okay, if the demand of water is more, then what kind of filter you have to design it. See, normally if the demand is very less, demand is very less, demand is less, then we'll go ahead with the flow sand filtration process. Okay, if the demand is more, then we'll go ahead with rapid. Okay, go ahead with rapid. This is what the hydraulic loading. Then method and intensity of cleaning. See, if it is manual cleaning, we'll go ahead with the slow sand filtration process. If it is the backwashing systems, we'll go ahead with the rapid sand filtration process. Then nature, size and depth of filter material. Okay, so what kind of materials you are using it? Okay, for example, sometimes you use anthracite, sometimes you'll use sand, sometimes you'll use gravels of different sizes. Okay, sometimes you'll use charcoal as a filter material. So then, based on that only, or based on that is one also criteria to decide the kind of filters. Okay, again, it depends on all the kind of water quality or the kind of raw water quality. Then the quality of product water. Okay, see, product water in the sense ultimately the outlet. See, after filtration and after filtration, whichever the water it is going to come out. After filtration, if any water is coming out, so what kind of quality you are expecting? The quality, whether you are expecting it for drinking purpose. So again here the quality of product water always will discuss with the help of with the help of the purpose. So what purpose we are going to serve? See, if after filtration process, if water, if you are sending it to any agriculture purpose, assume that, so that much filtration or that much quality is not required. Suppose if you are sending this to for any flushing systems, flushing of water, okay, that much it is not required. Only suppose if you are using it for some industrial purposes, okay, see what kind of quality you are expecting after filtration process. That is also one deciding factor. Okay, see for drinking, so how much efficiency I should get. Okay, so that is going to affect the overall design of the filtration process. Then normally this is the typical rapid sand filtration process. Here you can see the sand bed. Just a minute. Okay, of course, depending on the quality of the raw product water, or the product water. Okay, so we are going to decide the uh, the kind of filtration process we have to use it. Okay. Of course, this is a very important question in your examination. Why? Because uh, there's one common question will be there. Explain the rapid sand filtration process. Explain the slow sand filtration process. See what mechanisms it is going to work, and which are the deciding factors. It will be there. Okay, but has to be um, explained in detail. Okay, this is normally I am telling about the backwashing system. That is the backwashing system. How exactly it is going to work? Tell you some. I'll share some of the videos also, just to go through it how the backwashing is going to happen. Okay. In the previous diagram, I already explained that this is the tank. It will be there. So here one tank they are going to construct. Okay. So from the bottom, the water they are going to supply. Okay, for cleaning of the water, cleaning of the water, they are going to do it. So backwashing is accomplished by forcing the water or sometimes air, very important, forcing the water or the air. So sometimes you will blow the air, or sometimes you will allow the water to flow from the bottom. Okay, to clear the sand filters. What will happen is that once if you are sending from the bottom, there is a slight rise. Assume that this is the initial level of the bed. Assume that before backwashing, assume that this is the initial level of the bed. So once the backwashing water, okay, if it enters to this bed, there is a slightly rise in the bed. Okay, slightly it will be rise with this much height. Once you rise the bed, see whatever the particles which are entrapped into this, for example, this is sand, this is part. So in between, if any particle is accumulated, so then it will be pushed with the help of the water. Then it will be lifted up, including the filter bed. Then it will, the whatever the things will be there, it will come out. Okay, it will be come out, and this will be collected in one more trough. Normally we can call it as the backwash water trough. That normally we can call it as backwash water trough. It will be collected. The particles in the filter becomes suspended and releasing the trash in the particles. Normally it will be lifted up and it will be collected. You can see the particles here. Okay, see there is a slightly, this is a channel, you can see the section channel here. Okay, from the bottom it is being lifted up, the water is going and it is overflowing on this. Okay, it is overflowing on this and it will be collected here. Whatever uh, the particles which are entrapped into that sand bed, it will be removed at that point. Okay, or in this channel it will be collected. And again what will happen is that whatever the lifted, what I'm talking, whatever the lifted water, it will be there, it will be collected and it will be filtered, and again the water will be supplied to a consumers. It will not be wasted. Okay, so this is how you can see the uh, mechanism. See, I'm talking about once the backwash water, it will be there. Okay, it will be collected here. Okay, that we can call it as a gullets. Then it will go in terms of this under drainage systems. Okay. Then this one is backwash trough. What I am talking about? Backwash what? Water trough. Okay. Here you can see that air wall. Sometimes air will be entered. So this is going inside the backwashing systems. And flow control it will be there, and flow sensor it will be there. Flow control, what it will do is that it will control the flow of water, that is backwash water. So how much fast it is required to, suppose if the sand filter bed, assume that if the sand filter bed is completely clogged, so then the flow has to be increased, okay, with high velocity. Remember, with high velocity, you have to increase. Okay, with a high velocity you have to increase. Then you have to provide one flow sensor here. Okay, flow sensor in the sense, for example, it has to give the value, for example 1.2 um, meter cube per second is the flow rate, or whether it has to display whether we are going to 1.0 meter cube per second. So it has to display that value. For that reason, the flow sensor will be adopted. Then, this is what the particles which will be supported gravel. You have observed in the previous class, that is the schematic representation of the rapid sand filter, where you can observe that at the bottom the gravels will be there. Okay. See how you can see this is the sand bed, how it is lifting up in this figure. You can see that this is the previous case before. Okay, and after backwashing, we can see that the wall is, see here, if you observe this here it is wall is closed. Here the wall is open now. Remember here, okay, it is open. So once it is done, what will happen is that, okay, so the whatever the bed will be there, it will be lifted up. It will be lifted up and it will be collected here. You can see this is the trough. It will be collected and it will go. Okay, then the backwash water, it will go in this direction. You can see the direction here. Okay, it will come and it will be, and again it will be, again one mechanism is there, because this backwash water, what will happen is that it will contain lot of mud. Okay, that mud and everything, it has to be cleaned. Again the sand which is lost during the backwashing filtration process, that will be placed again here. See, after 1 or 2 years, every year you have to check the depth of the sand, because in initial stages what will happen is that while starting off your design, assume that the depth is around 1 meter. Okay, at the initial stage of designing. See, during the backwashing systems, around 1 to 2% of the sand is lost. So then after 1 or 2 years, it will become 1 meter, it will become 0.8 meters. Then whatever the left, that's 0.2 meters, 0.2 meters, that will be, again you have to fill it. Okay, again you have to fill that. Okay, that is the purpose of the backwashing systems. And in backwashing systems, um, most of the 99.99% of the particles will be removed. Okay, the mud particles or silt particles. Okay, but not the bacteria. Up to some extent you can remove, but it is very less efficient um, for removal of the pathogens. But the um, slow sand filtration process is more efficient for the um, removal of the pathogens. Okay. So this is uh, the end of your filtration process. So we have left with the, I have not solved the problems. Maybe if possible, I'll take up the problems of the coagulation, sedimentation, and the filtration, possible screening also. We'll start with the next class. Okay. If 2 to 3 class will engage here. Okay. Once this, if you completed this, then we'll left with the disinfection. Okay, and some of the membrane filtration processes. Membrane filtration processes that will see later. Okay, for your internals, um, up to here filtration process it will be there. So today we'll get the assignments.